Anybody? Well, how do I want to change the way this guy looks so that I can make it easier? Distribute is right. So come over here, distribute like so. And then you're going to get the integral of secant squared t plus secant t tangent t dt. And now these are two of our common trig derivatives, right? So the antiderivative of secant squared is tangent. And the antiderivative of secant t tangent t is just secant t. And we always want to include the plus c, so tack on the plus c, and that's our answer for this guy. Does that make sense for everybody? Is there any questions? We're actually kind of practicing for our quiz on Wednesday a little bit because this section and 3.9 have a lot of overlap. Okay. So let's try one more before I get to the more interesting things we want to work with. I want us to try number C here. So this is really a fundamental theorem of calculus part 2 question. And this is a definite integral. So a definite integral has these two limits of integration here. So your answer will be a number. So if this was your little f of x here, you're going to find the antiderivative, and then you're going to plug in 64, and you're going to plug in 0, and then you're going to get a number. So I want you to try to find the antiderivative of this inside first, and then plug in those two endpoints. So why don't you guys try this right now? I guess the first thing I would do is I would write this in exponential form. And then I've been trying to emphasize to you that we want to change the way this thing looks. So we're using trig identities or algebra. There's no trig here. So we're just trying to use some algebra to change the way this looks. The algebra idea we're using is distribution, which is the same idea we used on the previous problem. So then this guy becomes the integral from 0 to 64. When you have two functions with the same base multiplied together, you got to add the exponents. So I'll stretch this out a little bit. I'll put this as 3 to the 6 plus 2 to the 6 minus 1/2 plus 1 is 3/2. So you can write it like that. So here I'm just putting that 1/2 and the 1/3 under common denominators. And then this gives us the integral from 0 to 64, x to the 5/6 minus x to the 3/2 dx. Now, one mistake I've noticed students make is they do all this simplification and then they forget to actually find the antiderivative. So at this point, we should find the antiderivative. So to find the antiderivative, you got to add 1 to the exponent here. So that's going to give you x to the 11/6, and then you divide by what you just wrote. So dividing by 11/6 is the same thing as multiplying by 6/11. So we get that for the first term. For the second term, it's going to be, I'm going to add 1 to the exponent, so that's going to be x to the 5/2, and then dividing by 5/2 is the same thing as multiplying by 2/5. So we got 2/5 here like this. Is there any questions so far? Now, when we're doing a definite integral, as we had discussed last class, you don't need to put the plus c because you're just going to be subtracting two numbers anyways. You'd have plus c and then minus c, and then the c's would cancel out. So for definite integral, we just put a vertical line here and go 0 to 64. Like that. All right. And then we're going to plug in those numbers. So you're going to get 6/11, 64 to the 11/16, 11/6, sorry, minus 2/5 times 64 to the 5/2. That's the first thing when you plug in the 64. And then you're going to get minus 0 for the second term. Okay. Any questions so far? So what I would do is I would write this guy as 6/11, not pi, over 11. I'm going to have 64 to the 1/6 power. And then raise that to the 11th. So I'm taking the 11/6 fraction and I'm splitting it into two things. I'm going to do the same thing with the second one. It's going to be 2/5. We've got 64 to the 1/2 raised to the 5th power. So the idea here is that if you have x to the a to the b, that's the same thing as x to the a times b. So I like to do the denominator first because it's easier for me to find the 6th root of 64. So does anyone know what the 6th root of 64 is? That's a 2. So this would be equal to 6/11. You got 2 to the 11 minus 2/5. You guys know what the square root of 64 is? That's 8. So this will be 8 to the 5th. And if you actually wanted a number, you would pop those guys into your calculator. But I just kind of wanted to talk about how we could split this 11/6 up into the 6th root raised to the 11th power and so forth. So we'll just leave our answer like this. Is there any questions about this? All right.